All right, let's take a look at this your turn exercise. Now, I've already loaded the prerequisites, our packages of interest in the Boston data that we're going to use, and I've got my train and test split. So for this one, it said, using the Boston train data, fill in the blanks to create a recipe that one will model CMEDV, that's our response variable, as a function of all predictors. And then we want to standardize all numeric features, and we want to normalize all the numeric features with the Yao-Johnson transformation. So basically, we want to go ahead and take our numeric features that's within our Boston training data, and we want to correct for any kind of distributional assumption violations that we may have. Particular standardizing to get them all on the same scale, and normalizing so they all have a somewhat of a bell-shaped or normal distribution to them. All right, so what we need to do is create a recipe first. So we're going to go ahead, and here it said we want to have CMEDV is a function of all predictors, right? So recall that our shorthand for that is to use the period there. So now we're going to create our model, which is CMEDV. Our response variable is a function of all predictors. And what we want to do is we want to, step one is standardize all numeric features, right? So we can use normalize, step normalize to do that. And I can use the selector functions to call all numeric predictors. So this is going to apply this step, this feature engineering step, to all the numeric predictors. All right, the second one is we want to basically make sure all our predictive variables have a normal distribution. So we can do that, correcting any kind of skewness that exists, and we want to apply a Yao-Johnson, right? That's just in case there are any kind of non-negative values within our features. Yao-Johnson will allow that rather than like a box-cox or a log transformation. And again, we want to apply this to all numeric predictors. All right, and we could run this, and we have just created our recipe.